So let's prove the following. We'll start from the left hand side of a given expression. So on the left hand side we have tangent cubed theta divided by 1 plus tangent squared theta. Now 1 plus tangent squared theta, that's a standard identity which is given by secant squared theta. So that means in our denominator we're going to have secant squared theta. Plus the second term we have cotangent cubed theta divided by 1 plus cotangent squared theta. Now 1 plus cotangent squared theta. So this is another identity with the value cosec square theta. So that means in our denominator we're going to have cosecant q squared theta. Now what we'll do, we'll convert tangent to sine and cosine. So tangent cubed, that's the ratio sine cubed theta over cosine cubed theta multiplied to secant squared theta plus cotangent cubed theta, converting to the ratio cosine over sine, because we have cotangent cubed theta divided by sine cubed theta multiplied to cosecant squared theta. Now we know that the secant function, that is the reciprocal of the cos function or the cosine function. That means cosine of theta, that's equals to 1 over secant of theta. So the product goes cosine theta times secant of theta will be equals to 1. Similarly, sine and cosecant are reciprocal of each other. So that means we have sine theta times cosecant of theta with a value of 1. Now if we square this, we'll get cosine squared theta times secant squared theta equals to 1. Our denominator of our first term will be cosine theta. Similarly, applying the property that sine theta times cosecant theta equals to 1 and squaring both sides, we're going to get sine theta in the denominator. Now let's combine the two terms. So we'll have the common denominator of sine theta times cosine theta. And the numerator we have sine theta whole raised to the power of 4 plus cosine theta whole raised to the power of 4. Now that means we can use the property that whenever we have a raised to the power of 4 plus b raised to the power of 4, that this can be also expressed as a squared whole squared plus b squared whole squared, which will be then equals to a squared plus b squared whole squared minus 2 times a squared b squared. So let's apply this. So we're going to have, so in our case, so let's write it down. A is sine theta and b is cosine theta. So this is the result that we should obtain. So we will get in the numerator sine squared theta plus cosine squared theta whole squared minus 2 times a squared. So we have 2 times sine squared theta times cosine squared theta whole divided by sine theta times cosine theta. So sine squared theta plus cosine squared theta, this is a standard identity with a value of 1. So we finally get 1 minus 2 times sine squared theta times cosine squared theta whole divided by sine theta times cosine theta, and this is the expression on the right hand side. Hence we have successfully shown that the left hand side is equals to the right hand side, hence proved.